number 1, we're taking 2.39 times 10 to the 4th power. That means we're taking that decimal place right here and moving it 4 to the right. And when we do that, we end up with 23,900. Number 2, we're taking the decimal place and moving it 7 positions to the right. So we're going to move it 3 here. Oh, is that 7? So yeah, so it's being moved 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, ends up being 10,450,000. 3.7 times 10 to the 8. So now we're moving it 8 positions, and we end up with this massive number, 370 million. All right, now, number 4, now we have a negative exponent on 10, so that means we're going to end up with a tiny number. So we're taking our decimal place and moving it 6 to the left, and when we do that, we're going to end up with 0.00000084. And this makes it kind of look like I still have a decimal place here, which I don't. And here, let me fix that, 8, 4. All right, number 5, we have 1.0 times 10 to the negative 2. So again, we're going to be taking our decimal place and moving it 2 to the left. So it ends up going right here to 0.01. And then 9.2 times 10 to the negative 8 power. Yeah, it's going to move, to the left, 8 positions from 9, and you're going to end up with, I think, about 7 zeros in here. So it's 0.000000 or whatever. 7 zeros, 92. Okay, so I hope that makes sense now. And I hope you can see, how these numbers, can be much more compact than these numbers, these decimal numbers. These numbers in scientific notation can be a lot more compact than these other numbers, all these zeros that get really hard to see and everything. And so when you're doing science, you sometimes have to deal with really teeny tiny numbers. Let's say you're trying to measure bacterium, or you're doing something in astronomy and you're trying to measure distances between stars. The numbers can either be really, really tiny or very, very large, and they get to be unwieldy when you're doing a lot of calculations with them. And so scientific notation is just much easier to use in that case. All right, so let's move on to the next example. So far, in example 1, you've taken numbers from scientific notation and converted them back into decimal. And now we're going to do the opposite. We're going to be given some numbers that are in decimal, and we're going to convert those over to scientific notation. I sometimes think this is just a little bit trickier, and I think the easiest way to think about this is once you come up with the number, make sure that you can take the scientific notation and convert it back to the decimal. And if you can, then you know you have done it correctly. All right, so we want our number, our decimal, we want it to put it in here, right? So we're taking this bigger number and we're making it much smaller, right? So that means that you're going to make up for it by having a larger exponent and the as a power of 10. So how many decimal places are you going to be moving this? You're going to be moving it 1, 2, 3, 4. So here it is. So it's going to be to the 4th power. Now, if you were to take this and convert it back, do you get 34,000 back? Do you get 3.4 times 10 to the 4th power? Does that give you 34,000? Well, yes, it does, because you're going to move that decimal place 4 positions to the right. All right, now let's take B. It's 1.78. All right, well, it's pretty much already the decimal. We already have our 1 decimal there, right? And so it's pretty much in that form, but it's not times 10 anything. So we don't really want to change anything. We just want to multiply it by 1. So we're going to do that. If we're going to write it in scientific notation, it still needs to be times 10 to some power. But so we don't want to change anything about it. We're going to put it to the 0 power, right? Because that's really 1. So 1.78 times 10 to the 0 power is scientific notation for this number. And then, all right, now last number here, we're going to do 0.0007. Okay, all right, so this is a little tiny number. We're going to write it as 7.0. So I'm writing as a bigger number, but I'm going to make up for the difference there by making a negative exponent here. And we're moving this 1, 2, 3, 4. So it's -4. So if I were to convert this back to this, would I get that? Yeah, because I would take this decimal and move it 4 in the left direction, and I would get that number back. All right. Now, what I want you to do is I want you to do the checkpoint and then come back and check in on the next video.